Okay, let's take a look at using the TI-Nspire to find the second derivative and to really find our inflection points and intervals of concave up and concave down using the second derivative test. Okay, so the first thing we're going to do here is we have this function, right? We have this 3x to the fourth minus 4x cubed plus 2. I got to go over to my calculator and I want to enter that and store it as f of x. So I'm going to go ahead and do that. And store as f of x. Now we want to get the second derivative of this function. Well, in order to do that, we got to get the first derivative before we can get the second derivative. So I'm going to go ahead and take the derivative of f of x, and that is going to give me my first derivative. I'll save that as g of x. Okay, so I go Control VAR to store, and that's my g of x. So now, if I need to get to the second derivative, now I got to take the derivative of g of x. So I'm going to go ahead and do that. And so we got g of x here, and we hit enter, and then Control VAR, and let's store that as h of x. So we hit enter here, and now if I can set my second derivative equal to 0, it's going to give me the inflection points of this original function f of x. So I'm going to go ahead and do that, and to do it, we go to Menu, Algebra, Solve, and we're going to say h of x equals 0, comma, x, and we hit enter, and we get two answers, 0 and 2/3. All right, now what I like to do here is I like to kind of set up a number line to help solve this. And that's just going to help me organize my information so that I know both where my inflection points are, and also I know intervals of concave up and down here after I use the second derivative and do the second derivative test. Okay, so I got 0 and 2/3, right? So now I can go here and look at values before and after these two numbers, and those will tell me whether it's going concave up and concave down. So if I input a value and I get a positive number, it's concave up. And if I input a value and I get a negative number, it's concave down. All right, so I'm going to go right before 0. I'm just going to input -1. Remember, we're using second derivative here, which I've saved as h. And that gives me a positive number. Okay, so I'm going to go ahead and record that. That means it's concave up here. Now, in a polynomial like this, it's just going to alternate. But let's just put in values just to make sure. So between 0 and 2/3, right, we could put in 1/2. So I'll put in 1/2 here, and we get a negative number like we thought. Right, so that means it's concave down. So we'll just record an arrow going down. And then if we put in a number larger than 2/3, which would be 1 or 2 or 3, it doesn't really matter what you put in 100. Let's put in 100. Okay, if we put in 100, we get a huge number, right? If you were to input like 2, you would just get a smaller positive number. That's still a pretty large number. But either way, we get a positive number, meaning it's going to be concave up from 2/3 to infinity. Okay, now before I'm going to go ahead and write all my information here, and I'll be done with this problem. But before I write my inflection points, well, I need to know the y values of both of them, right? So in order to do that, I'm going to go over to my calculator one more time, and I'm going to input 0 and see what I get for my y value. Now remember, when we input values, we need the coordinate point on the original graph. So that's why I'm going to input 0. So I input 0, and I get 2. So that's going to be my y value in this first one, 0, 2. And then I got one more inflection point here at 2/3. So I'll go ahead and input f of 2/3 over here. So input f of 2/3, and that gives me 38/27. So there's my other y value. So 38/27. So I have two inflection points here. And the last thing I just need to do is say that f of x is concave up on -infinity to 0, and then again from 2/3 to infinity. and then f of x is concave down, and that's just going to be in this middle interval from 0 to 2/3. So now I've got all my information. I have my inflection points and intervals of concave up and concave down. So I'm done with this problem. Let's try a harder one, and one that maybe doesn't alternate, and let's look at it again. Okay, so here's our second problem. Use the second derivative test to find the inflection points. Same as before, but now we have a fraction here with some x in the denominator, which will mean this will have some vertical asymptotes and it'll be slightly different. Okay, so let's start though. We're just going to clear our scratch pad and start a new problem here. And I want to do just what I did last time, and I'm going to save this function as f of x. Okay, so I'm going to start with, sometimes when you need a negative out front, you got to put this negative sign like this. And then I'm going to put my fraction tool here, and that's going to give me negative x cubed. Make sure you got that negative out front for a problem like this, because if you don't, well, you won't get the right answer. So I'm going to go ahead and store this as f of x. And now I need to get to the second derivative, right? So let's start with the first derivative. Calculus derivative, and I'm going to use f of x to get the first derivative. You can ignore this sign. This is your derivative of the f of x. So we're going to save that as g of x. And we're going to hit enter. And then let's go one more so we can get to the second derivative. So we go menu, calculus, derivative again, and now we're going to take g of x because we're going first derivative to second derivative. And again, ignore this this caution sign. It just has to do with the x in the denominator, but now we get our second derivative. So we're going to store that as h of x. Okay. First thing we need to do here is we need to use menu, algebra to solve, and we need to figure out where the second derivative is equal to 0. So if we do that, we actually only get one answer. We just get 0. But we have one other thing going on. Remember, the original function, right, has a denominator here that is going to have vertical asymptotes. So whenever that's equal to 0, that means we have vertical asymptotes. So you can do this a couple ways, but let's set up our number line. Let's put our 0 first. That's going to be our only inflection point. So actually, you could input that into your original function right now and just record the inflection point since it's the only one. So it's 0, 0, but you could also look at this and see that it would be like 0 over -4. 0 over 4 is just 0. So let's record our inflection point before we do the rest of this problem. So we got our inflection point at 0, 0. So that's my only inflection point, right? Now it wouldn't always be 0, but it just happens to be 0 because of the nature of this function. Now the next thing I need to do is I need to set the denominator equal to 0 in order to get my x values for the VA. So this you can do by hand. It's pretty easy. X squared equals 4, so take the square root of both sides, and x equals plus or minus 2. That means this function has vertical asymptotes at x equals -2 and x equals 2. And you can put a dotted line just to remind yourself that those are not inflection points, but those are vertical asymptotes. So now, back to our second derivative test, because we need to figure out where it's concave up and concave down. So now I need to test values before and after all of these numbers, -2, 0, and 2, to figure out where it's concave up and concave down. So I'm going to start with -3. Notice I'm using my second derivative. That's why we call it second derivative test, and I get a really big positive number. So that means that it is concave up, because it's positive, before -2. So let's input -1. Oops. And put it into our calculator, -1, and we're going to get a negative number. Okay, so that means it's concave down in this next interval. Okay, now let's do it again. We're going to use +1 between 0 and 2, and that gives us positive now. So it is alternating, but it just happens to be alternating. Let's see if the last one is alternating as well, or it might be up at the top. So now we're going to input our last value, which is 3, and we get a negative number. So it does alternate. But the important thing to remember here is because this was a fraction, we needed to evaluate in terms of the vertical asymptotes as well as our inflection point. So we have our inflection point, and then let's record our intervals of concave up and concave down. So f of x is concave up on negative infinity to negative 2. And even if like it kept going concave up, you still got to put a break at negative 2 because remember that's a vertical asymptote. 0 to 2, and then f of x is concave down on negative 2 to 0, and again from 2 to infinity. And now we finish this problem.